So, coming to the fifth task, which is uh, to find accuracy of Navier SSVN and KNN for a chosen data set, and also handling EDA, each and everything. So coming to the fifth one, I have taken the data sets as diabetics. So, and the diabetics is all numeric, and it has some null values also, I guess. So the EDA has been performed, and the first one is to drop all the NaN values, and also if the column is a non-numeric value, it will be defined, and then it will check whether if the column has none values or not. If yes, and they will be handled. But I have checked it twice, but I didn't find any null values, so I have not handled them. And I have split it X train and Y train, and have done the SVC accuracy, Gaussian bias accuracy, and KNN accuracy, the train X and test train. So running it, so the null features, the features of the null count will be 0 for each and every column or each and every feature. So when coming to the accuracy, SVC accuracy has 0.66, 0.65 for train and test, whereas NavBS has 0.78, 0.4 for train and test, and KNN has 0.81. We can always see like KNN takes a little bit time and a lot of RAM rather than base and SVM. SVM is very good for two-dimensional, and base is also runs good on two-dimensional, but KNN will give you a more detailed and detailed accuracy when you run it, but it takes a lot of time because it does the hyperbolic thing, and it's for the more complex data than the simple data. So when going to the sixth task is to find the k number of clusters using k means elbow method, and then finding the Shillot score while performing the EDA. So for the sixth task, I have taken the iris data set. So in the iris data set, I have like 4 5 petal length, petal width, and class. So and the last thing, which is so I have taken the iris CSV and loaded it as a data, and then I have split it into two ways, as a staple length and width as x and y, and then I have showed all the scattered plots before the cleaning or scaling the data set. Once the cleaning of the data is done, I have even plotted the same graph so that we can visualize the difference between x and before pre-cleaned and after cleaning. Once we cleaned it, I have founded the k number of clusters with using the elbow method, and then plotted it according to it. So it would be visualization for us. So it would be an easy to find the k number of clusters. So to find the k numbers of clusters, there's like a distortion method. So right over here, this code snippet will be helping to find the k, the elbow method, and then once the k is found out with the prediction scores, we have found the Shillot score, which is the range. The range is from -1 to 1, where the positive is a very good score for the model. So when you run it, you get first the first the pre-clean data set. So it must be a little clarity when the data set is cleared, and then once you can see the elbow method, where the second distortion is about 3. So we have taken the clay as in 3 as the clusters, and score, we have the score as 0.38, which is a which is non-error and a good score, I guess. And thank you, that's it.